Bienvenidos, Ushamdi, and welcome CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4, or the Cisco Networking Academy Connecting Networks V6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 3.4.2.4, where we're going to take our first look at configuring the generic routing encapsulation. We're going to see how we're going to create some virtual tunnel interfaces over which we can tunnel, right, or encapsulate different types of traffic. And so here is our configuration, and this is a fantastic activity to sort of ease us into GRE and how GRE specifically is going to work. And so you can see here they call out the GRE tunnel, and so that is the GRE tunnel. Now, some key things to take away and that we need to talk about here. Let's remember that this is a virtual interface, right? It's going to be a tunnel interface, but it is virtual. Think of it as like a loopback address. The difference being is that we're going to be calling it a tunnel, but it's the same in the sense that they are both virtual. The GRE tunnel interface does not physically reside on the router. So in other words, there's not an interface right here called TU0. There is no physical interface. We're going to create the virtual interface that will run over this outbound internet-facing interface. And so when we talked in class a couple weeks ago about different types of configurations, let's say that this is Office A, or I'll say this is Office B down here. We'll just say Office B, and that this is Office A, right? And this office can be in New York, and this office can be in Los Angeles, right? And so the question or the challenge becomes, I want the LAN, right? Because this is a LAN segment here in New York. I want the individuals on this LAN to be able to communicate with the individuals on the LA local area network. And we have a small office, right? We've got a connection here that could, Comcast, Verizon, whatever the case may be. And the same thing is true here. Now, here are our internet routable IPs. And you can see that we've got /30s, right? Now, we talked about some different ways that we could do this. And NAT is certainly one way that you could facilitate this. But what if we started adding tons and tons of nodes over here, right? Maybe different networks. That starts to become a little more complicated. So one of the things that we can do is we can do a generic routing encapsulation tunnel, or a GRE tunnel. Now, just like we spoke about HDLC, right? Cisco put in that little extra field for the protocol. The same is going to be true when we're talking about GRE. And so what do I mean by that? Well, GRE, we call it a tunnel, and the reason we say that it's a tunnel is because you're actually encapsulating, and let me start again here. I'm kind of getting carried away with my drawing. So you're actually encapsulating what would be the normal payload. And so let me put it in here like this. I'm trying to make sure we got enough room here. And we'll do, that's probably good enough there. So here's what it's going to look like, right? So we've got the data. Here's our TCP information, right, at layer 4. So here's layer 4. And this is layers 5 through 7, application presentation session. And then we've got the IP. And we're talking about IP as the passenger, right? The passenger that's going to be riding in this tunnel. And so here's our layer 3. Now, in a typical communication, right, this would be typically, again, I'm saying typical, this would be layer 2, and that would be our layer 1 information, right? But we're not talking about typical here. What I'm doing is, and let me do Control Z and pull those back. So what we're talking about here is we're talking about encapsulating, right? And by encapsulating, I mean I'm going to be putting, and let me change colors here very briefly. Let's change this to, what do we got here? Change to black. I'm going to be adding or encapsulating the IP payload, right? And this is the payload over here. Because this is what would normally be exchanged, and this is what would normally be floating around on the internet, right, in terms of our traffic, right, as we've got the IP layer 3, the TCP layer 4 information, could be UDP, right, and then the data, right, whatever's going to be in that data. Now, with GRE, Generic Routing Encapsulation, what we do here is we put a GRE header. So we throw on another header, and what this header is going to identify is the payload type. And so 0x, and we saw this, I believe this is in the textbook, 0x, I think it's 0800 or 0x800, but that's IP, right? And all this is saying is that what I'm carrying with me here is IP, and it's based off of what's in this layer 3 field, right? So the GRE header says, hey, I've got IP. Now, there are some flags that are in here as well, but there's another part, and it's the IP, right? And so what we're carrying is not only information that is indicating, you know, hey, this is IP that I'm encapsulating here. And by encapsulating, again, I'm clicking on, or I'm adding, prepending this additional header and taking the IP information and bringing it out here, right? So this is how it allows me to encapsulate it or to tunnel over this internet infrastructure, right? And so that's what's happening here. And that is how we tunnel over the internet. So when it goes out, right, the source IP address and the destination IP address for the tunnel, we're going to configure that depending on which way you're going, right? So if we're going this way, that's my source and that's the destination. If we're going the other way, coming this way, that's my source address right there, and that's the destination address for the tunnel interface. And that's this outer IP header that's going to be carrying that information, right? So it's similar, again, similar IP address information, but we've got our source and destination because this is going to be seen first, and that's going to have these outer addresses, and then this has my inner information, right? That I'm going maybe from this network to that network, or, you know, from this PC to this PC. And so that's what's happening here. And we call GRE, it's commonly referred to as an overlay, right? And the reason we call it an overlay is because we are laying GRE on top of IP, right? We're overlaying the GRE on top of the IP. We are creating a point-to-point tunnel, right? And remember, I said this is one of the challenges that you start to run into if maybe, let's say, you start up a third office, right? That's got all your stuff behind it. And then a fourth office, and a fourth office, and then a fifth office. And there's your routers. So, and now you want all these offices to be able to communicate with all of these other offices. You run into that n times n minus 1 divided by 2, that full mesh. If I want to have a full mesh and allow all of these nodes to speak to any other node directly across the internet via a GRE tunnel, then I run into this equation. And with 5 sites, it would be 5 times 4 divided by 2 gives us 10, right? 5 times 4, 20 divided by 2 is 10. So we would end up with 10 GRE tunnels per, was that per router? Well, no, I guess you'd end up with 10 GRE tunnels needing to be established between all of these routers to provide that full mesh capability, because I'd need a tunnel here, a tunnel here, a tunnel here, right? And then a tunnel here, a tunnel here, a tunnel here. So we end up with, and then, you know, the tunnel here, we end up with all kinds of tunnels in order to facilitate that. And so that starts to become very cumbersome in terms of configuration overhead. But again, remember, we're focused on GRE. The chapter slowly and gently introduces you to mGRE, which is what DMVPN is based on. Dynamic Multipoint Virtual Private Network, right? And that's what the M stands for here, and it's actually a lowercase m. Try to draw that a little more lowercase-like. Multipoint GRE, right? And what multipoint GRE and what DMVPN can do, and there's next hop resolution protocol is another protocol that DMVPN leverages. And what that allows is that allows for a single hub, right? A single hub site, or you could have dual, you could have two routers here, but a single hub, and the spokes, which are these guys out here, register with the hub. And when they register, they're going to learn about the outer, right, that public destination IP address. They're going to learn. So router B, when he registers with router A, and again, this is DMVPN with multipoint GRE, he's going to learn about the public IP addresses of all of these other spokes, because all of that information is cached here on the hub, right? And so when a spoke registers with the hub, he learns about the other spokes. And not only does he learn about the other spokes, he can then directly create a GRE, or in this case, a mGRE tunnel directly to the spoke. So he doesn't have to go through the hub to get to the spoke. He goes direct to the spoke. And that technology, you can see the need, right? The killer application of that technology is, I have 100 sites around the world, and I need to be able to communicate not only between the spokes, right, all the sites that are out there, and the single hub site, or maybe a couple hub sites, but I need the spokes to be able to communicate directly with each other, right? So it kind of creates this pseudo point-to-point connection, allowing me to go direct spoke to spoke. All right, so that's a lot of information, but we want to talk about the background of this, because again, the reason that they're covering, and if you're scratching your head saying, well, I don't understand why Chapter 3 even brings GRE into the equation, right? It brings it into the equation to begin the conversation about multi-point GRE, which is then going to lead to DMVPN. And remember, DMVPN, the reason that we see frame relay going away from a curriculum perspective is that DMVPN is the replacement, right? It is the non-broadcast multi-access, the NBMA replacement for frame relay. And that's why frame relay is kind of going away from a curriculum perspective. And in the industry, it's going away because there are other technologies that are simply better, faster, cheaper, more flexible than frame relay. But in the curriculum conversation, DMVPN is going to be replacing frame relay as the NBMA topology. So that is GRE and DMVPN and multipoint GRE. And again, I always bring this up, and there are many, many free resources that are out there, but from a Cisco perspective, there are not too many that are as good as Cisco Live. Now, this is free. So if you were to go to CiscoLive365.com, you can sign up for an account. You can see right here, create an account for free. And that is going to get you access to 5,000 sessions. Now, you may be asking, well, why are you bringing this up? Well, here, let's take a look. Look at the events. Whoops. Look at the different events. Look at it goes back until 2014, right? So if I'm interested in DMVPN, right, I'm going to click on 2017 Las Vegas. I'm going to type in DMVPN and hit enter. And take a look at this. These are sessions that you can not only download the PowerPoint presentations in PDF format from the presentation, but you can actually watch the session. So advanced concepts of DMVPN or demystifying, this is a great place to start if you wanted to learn more about DMVPN. So you can come and click on that link, take a look. You can watch the session. You can download the PDF, which are it's the PowerPoint slides from the session. You can download that slide deck and work through the slides while you watch the session for free, right? It doesn't get much better than that. And so here is the DMVPN overview, right? And again, when you listen to the session, and you can actually, like I said, you see the video from the session of the presenter, they walk through everything. They go through these slides, they explain what's happening, they explain why DMVPN exists, right? Here's some different topologies. And again, it's a great way to get additional information. Now, there's one session in particular, and if I was to go back to view all sessions here, and hopefully it's going to take me back, and let's put DMVPN in again. Advanced concepts of DMVPN. And actually, wait a second, I'm sorry, it took me to 2014. So we want to go to 2017. So again, let me click on technology, event, and 2017 Vegas, and DMVPN. And this session right here, right? So Mike Sullenberger, for those of you that aren't familiar with DMVPN and are just getting into Cisco or haven't attended a Cisco Live, Mike Sullenberger is actually the individual who came up with the idea of DMVPN. And in this video, in this session, he talks about how it was that he came up with it and the problem that he was trying to solve, and how he basically stitched together multi-point GRE and the next top resolution protocol, and how he was able to, get IPsec involved in the equation to provide security. He is the creator of DMVPN. And again, this is free. You can get his entire session. So I highly, highly recommend that you take a look at those sessions to start sort of orienting yourself toward DMVPN and to give you a pretty good foundation of how to go about configuring DMVPN and sort of demystifying DMVPN. So let's jump into this activity now. And again, very easy activity here, right? It's going to walk us through the steps, but this is fantastic. It's a great introduction into the generic routing encapsulation. So let's get on to router A here, and let's pull router A up. We'll bring router A up toward the top of the screen. And let's give ourselves some more room here. And let's jump on to, let's jump onto the CLI for router A. We're going to need a little more space than that. All right, so here we are on router A. So let's go from user exec to privilege exec, and let's say show IP interface, interface brief. And we're going to need even more space. I thought we'd be able to avoid the wraparound there. And so here we go. You can see that we've got our gigabit Ethernet interfaces, our serial interface, and that's our internet-facing interface. Here's our RFC 1918 address for the LAN segment that sits behind router A. Now let's pull up router B, and we'll bring router B down here. First, let's stretch it out a little bit. And so see if we can't I don't think we can get them both up at the same time. So we'll go to privilege exec mode. We'll say show IP interface brief, right? And again, only two things configured here. The gig00 LAN interface, and that's our default gateway for all the hosts, PCA and PCB in this case. And there's our internet-facing address. So what are we going to do? We're going to configure the tunnel interface of router A. So let's bring router A back up. So how do we do that? Well, we go into global config, and here's where we say, if I say interface into a question mark, you can see we can go into the serial interfaces. We can do port channel that we did when we did ether channel, right, with LACP and PAGP. And there it is, a tunnel interface, a virtual tunnel interface. So I'm going to say interface tunnel, and as you can see, you can create quite a few tunnels here. In fact, what is that? The billion? 1, 2, 3. Yeah. So 2.14 billion tunnel interfaces that can be created, right? So we've got our choice of number. And this is arbitrary. They don't have to be in order, right? But let me stress this. Whatever you do, always, always, always ensure that if you can, whatever tunnel number I'm using on router A, I use the same tunnel number over on router B, because there's nothing more annoying than trying to troubleshoot a GRE tunnel and the tunnel number is 55 on one side, and then you log into the other router and it's 832, right? And if there's lots of tunnel interfaces, this can become very painful very quick. So always, always, always use the same number for the tunnel interface, that virtual interface, that virtual point-to-point interface on both sides of the tunnel. So for here, we'll simply say tunnel 0. And again, I could have said tunnel 22, right? I get to pick, right? You get to pick. So we'll say interface tunnel 0. You can say it shows that the interface do show IP interface brief. That the tunnel is up. Now the tunnel is up. And again, this makes great sense. Coming off of the conversation of PPP and HDLC and what we see when we have an encapsulation mismatch, this makes perfect sense to us. Layer 1 is up. And layer 1, the status, it will always be up. It's just like a loopback interface, right? It is always up at layer 1 because it is virtual, unless I shut it down, right? Unless I go in administratively and say shut, this is going to be up. Now, it's down at layer 2 because, again, this is a point-to-point interface. Cisco will treat this as a point-to-point interface, and you'll see that OSPF, when we do our OSPF configuration, is also going to treat this as a point-to-point interface. And so what's going on here is the Cisco router is telling you, hey, I sense the interface is up at layer 1, and in this context, it's because it's configured, right? It's virtual. As soon as I configure it, boom, we're up. But I'm down because the remote end of this tunnel, I sense nothing, right? There's nothing there, right? So we have to remedy this. So let's go ahead and jump in. And GRE, a point-to-point GRE tunnel in and of itself is a very straightforward setup. We create the tunnel interface. We're going to do a source and destination. So my tunnel source is going to be that outgoing interface, serial 000, and then my tunnel destination is going to be the publicly reachable IP of router B. Now, I don't make it this 10-10-10. That's not the destination, right? And so that's one thing that confuses learners is when they look at this tunnel, right? They say, oh, I have a tunnel interface. Here's my source, and here's my destination settings. Not the case, right? Not the case. This will be the IP of the tunnel interface, right? And think of it like this. And here's how you can think of it. Think of it as a serial interface running between these two routers, right? And this is going to be the IP address on this side. You can see it's a /30 because it's a point-to-point setup. And they're on the same broadcast, well, they're on the same subnet. Let me say that, right? They're on the same subnet here because it's just like it's like a virtual serial link running between these two routers. And this is the IP of the tunnel interface on that side, right? Now, it's virtual, okay, and I'm going to do the little lines here between. It's virtual because it's actually, the traffic's actually going across the internet, right? But think of it as like this virtual interface here. It's a point-to-point connection. So the source of that is going to be the outgoing interface on this router because it's publicly reachable. Because again, we're going over the internet. So the source is going to be my outgoing interface is the 64.103.211.0 subnet. And the destination is that publicly reachable IP. And it's going to be the reverse on the router B side, where that would be the source interface because it'll go out with that IP address, or it's going to be either .1 or .2. So it's going to go out with that subnet. And then it's the same thing here, that traffic that egresses that interface will go out for this tunnel is going to go out with that as the tunnel source, and this is the tunnel destination. And that's how the communication is established. And then it's going to bring up at layer 2, this will come up, and we will have a virtual, right? A virtual tunnel interface that makes router A and router B think, it's faking them out, making them think, hey, I've got a point-to-point interface between these two sites. And that is how traffic from these LANs is going to travel. It's going to be encapsulated in the GRE overlay, right? Because we got the outer IP address information, followed by the GRE header, which is going to have any flags in that 0x0800 in this case. And then it's going to have, and I'll switch the colors around this time, I guess, then it's going to have the payload, right? Which is the true source and destination for these LAN segments, the layer 4 information, and then my data, layer 5 through layer 7, right? Whoops, the pen is dying on me there. And that is what's happening. That is what the tunnel is all about. So let's pull, and where were we at? Router A here, and we have the tunnel destination. I think I left it off. So the tunnel destination, again, is that publicly reachable IP, 209.165.122.2. And now take a look. The protocol has changed to up. Now, there's a couple things that we're still missing here if I say do show run, and they're kind of spelled out there on the other side. Or I should say to the right there, they're spelled out. But let's take a look at our tunnel interface. Now, something that happened here, right, and we'll talk about this, that does not typically happen by default. This is a packet tracer convention here. I can almost guarantee that, is that I do not see this happening. And we're talking about the MTU, the maximum transmission unit, right, that can be sent across the tunnel. Now, by default, with IP, it's 1500. So it raises the question as to why is the IP shrunk, or I'm sorry, why is the MTU shrunk to 1476? And the difference, right, the delta between the default MTU of 1500 and 1476 is 24. And it's no coincidence that the GRE header and the IP information that it pulls, that it prepends, right? And again, when I say IP, I'm referring, this is, the whole thing is the GRE header, right? Is 24 bytes. So we need to adjust the MTU down because we're no longer going to be sending a maximum of 1500, right? Or the maximum wouldn't be 1500. We need to shrink it to 1476 to accommodate this extra 24 bytes of GRE header information. But again, this is typically something that you end up setting, right? That you're going to have to remember to set. It's like just like PPPoE, right? Remember, there's 8 additional bytes, so we drop the MTU to 1492 to accommodate those additional 8 bytes of header information. That's why you're seeing that change there. Okay, so we've got the tunnel source. We've got the tunnel destination, but you'll notice we don't have an IP address. Remember, this is a virtual point-to-point link. So we need to get the IP address on here of 10.10.10.1, and this is a /30, 252. So now I've got the IP address on there, the tunnel source, and the tunnel destination. Now, this becomes very interesting, right? And I know why they have you put this on here. So you can see here, tunnel mode GRE IP, that command right there. Now they want us to apply that command here. And if I were to say tunnel mode GRE question mark, you can see that it's IP. So we're basically saying that this is over IP. And this brings up the conversation about the passenger, the carrier, and the transport. And if you've ever watched me draw, you know that my art is definitely not that good, and that is left over from our our EIGRP conversation days. You know that my art is not that good, so I'm giving it my best shot here. And this is one of the best analogies I've ever seen. I've been using this for quite some time. So the transport, the carrier, and the passenger. So the carrier, and that's what we're saying when we're saying or I shouldn't say the carrier, the transport. When I say tunnel mode GRE IP, I'm saying that that's our transport, is we are using IP. This is going to be a GRE over IP tunnel, and that over it's the overlay, right? So I'm going to draw a picture here. I'm going to do my best to try to demonstrate this, right? So here's a truck, right? And he's out there, he's driving along the highway, okay? Now, think of the truck as the carrier, GRE. He is the carrier, right? Because, what do you see when you're driving out on the freeway and you see the trucks that are driving along? They have the company name. They have the name of the carrier is on the side of the truck. And so the name of this carrier is GRE. So we'll say this is GRE Industries. He's my carrier, right? And we'll add some bling to the wheels here. So he's my GRE. He's the carrier. So GRE is carrying what? What is it transporting? It is transporting, who's the passenger? Well, the passenger, right? We'll draw some people here. Here are the passengers that are in the back of the truck, right? And these passengers are all IPv4 passengers. Okay? So here is the carrier. GRE is the carrier. What is it carrying? What is it transporting? What is the cargo? It is IPv4. And then what is the transport? In other words, on what kind of a superhighway is the carrier transporting his payload? He's doing that on the IPv4 superhighway, right? So when I say tunnel mode GRE IP, wait, tunnel mode GRE IP, let me make sure I get that right. I apologize. Let me flip back and make sure I get this command correct. And I think I need to come out of this mode here. Yeah, tunnel mode GRE IP, sorry. What did I say there? Yeah, tunnel mode GRE IP. So when I say tunnel mode GRE IP, right, I am stating that this is a GRE over, and this truck is over IPv4. If I was to say tunnel mode GRE, and I think you can say IPv6, in fact, if we were to transition for V6 over V4, right? Because you're not limited to just doing IPv4, and that is let's clear the screen here and let's go back to this. That's a Juniper router, so we won't do it there. If I was to come here and get into global config and say interface tunnel 0 and say tunnel mode GRE question mark, take a look. I can do IP, I can do IPv6, right? So it's over. So the GRE is being overlaid on top of what transport protocol? IP, IPv6, or I can do multipoint, right? mGRE, right? So if I was to say multipoint, right? Now, here's the key, and this is what we're trying to get to in this conversation, is that command. If I said nothing more than tunnel mode GRE, the default is IP, right? So by default, the tunnel will be IP. So when I say tunnel mode GRE question mark, I don't have to do this command, right? The reason that they're showing you that command is because tunnels are new, right? And you need to understand how to say that, oh yeah, I'm doing this over IP, right? It's over a transport that's IP. So you would say tunnel mode GRE IP. Do show run interface tunnel 0. How do I know that's the default? Exactly, because it's not being shown here, right? Again, it's one of those Cisco things where, and I'm sure it's for more reasons other than it makes interesting test questions, but this is very important. You don't actually have to say tunnel mode GRE IP because that's the default. But we need to understand, right, that that would be the command that you would enter in. Maybe, who knows, maybe on this thing it's tunnel mode GRE, and I'll say IPv6, right? And then we say do show run. Now it shows up because that's not the default. But by default, the command is tunnel mode GRE IP. So we're going to say tunnel mode GRE IP, and I'm going to say no shut. Let's say do show run. And let's look at our first tunnel interface, right? So and the other thing you'll notice is, where is that handy dandy IP MTU, or the MTU 1476? You see how we have it here, right? MTU 1476, where is that? Again, on real Cisco routers, you are going to have to say MTU, IP MTU, I had it right, IP MTU 1476. Packets may be dropped, and that's fine. So, but again, do show run, and do show run interface tunnel 0, and there you have the IP MTU, right, of 1476. And so this is very, very important, right? Very important to understand that you are going to have to put that MTU in a real scenario, and the tunnel mode GRE IP, and take a look. I'm actually happy that they don't show that here because that's the default, right? We don't need to put that command in there, but we're sending IP traffic over GRE. We're going over that IPv4 transport, okay? All right, so that's on router A. We're going to do the same thing on router B. So let's bring router B into the fold. And again, very straightforward. Get into global config, interface, I'm sorry, I forgot my T there. We're going to go into interface tunnel 0. I'm going to say, and it's going to be up at layer 1, so I'll say no shut anyway. We'll say IP address 10.10.10.2. Remember, this is the tunnel, that point-to-point virtual link between these two routers, 255.252. We're going to put the tunnel source in here as serial 000, and the tunnel destination is going to be that 64.103.211. And now I need to look over here. What is that address up in the addressing table? .2. Whoops, .2. Now, I'm going to say tunnel mode GRE IP, understanding that that is the default, and IP MTU 1476. They just want MTU 1476. All right, 1476. Oh, and they're not even going to allow you to enter it in. Okay, so maybe it's because they don't allow you to enter it in that they automatically put that in here for you. And there we go. And so there is our tunnel interface over here on router B. And I'm going to give us a little more space here with router B, and we'll do the same with router A. So now, if I was to say do show IP interface brief, take a look at this. I have a tunnel interface that shows that it's up. What if I was to say do ping 10.10.10.1? Because remember, it sees it as a point-to-point directly connected interface. So sure, I can ping it, right? But here's the question, right? And we're getting ready to address this, right? So now that I have this tunnel interface here, and this is all fine and dandy, right? So here's my point-to-point virtual tunnel interface between these two routers. The traffic, right, physically, right, the traffic is going this way and the traffic is going this way. It's going out over the internet, but the routers believe, they've been tricked to believe, configured is probably a better way to, they've been configured to believe that this is a point-to-point interface here. because the GRE encapsulation is allowing us to get away with that. So we have this point-to-point interface. So you're probably thinking, okay, well, if I have this point-to-point interface here, can I ping the 192.168.2 and the 192.168.1, right? So from PCB, the traffic should go like this, right? And from PCA, the traffic should go like that. Well, I'm going to leave that drawing there for a second, and let's take a look at that. So if I pull up PCA, and let's get PCA. So I'm going to pull PCA up here, and we're going to pull it over to the right-hand side. That way we can leave the drawing in place. And the PCs are lagging a little bit here. There we go. All right, okay, a little better response time. So here we are on the PC. We'll go to the desktop. We'll go to the command prompt, and I'm going to say ping, and let's ping our default gateway, 192.168, and I'm on PCA, correct? Yeah, 1.1. And that's my default gateway. So I can ping my default gateway, and we would expect that, yeah, you can do that. That should work. Now let me see, can I ping 10.10.10.1, which is the virtual tunnel interface that is on this router, which is my default gateway. So can I ping that tunnel interface? I sure can, right? Because the PC, I issue this ping, and the PC says, whoa, 10.10.10.1. The PC looks in its routing table and says, hey, that's not local to me, but I have a default gateway, and I know how to get to router A. So I'm going to throw that traffic to router A. And then router A says, well, yeah, that's a locally defined interface on this router. So sure, right? You've reached the destination. Can I ping across the tunnel? Let's see what happens. Because the traffic is going to get sent here, right, to router A. But take a look at what happens. We've got our first request is going to time out. So the requests are timing out because I'm unable to ping the other side of the tunnel. So if I can't ping the other side of the tunnel, could I ping PCB, who is 192.168.2. Is it 2? And there's a typo here. This says PCC. That should be PCB. I'm hoping it should be PCB. So can I ping PCB, right, which is listed as PCC in the table, the addressing table? And the answer is no. And the reason for this, right, so take a look. Step 3 here. If I come to router A and I say, do show IP route, right, where in the routing table is my information for the 192.168.2 network? Where is that? Exactly, it's not there. Now, this answers the question. So take a look at what we do have configured. We have a default static route configured on router A. My guess is, if I come to router B, do show IP route, and let me go ahead. I think we're good with that there. Let me get rid of that. Yeah, we have a default static route, and look at the outgoing interface configured on both router A and router B. This is the default outgoing interface here. So when I pinged 10.10.10.1, that wasn't an issue, right? Because that interface is physically here on the router. When I said 10.10.10.2, I did this, right? I went out, and that is why I shouldn't say that is why. And that's because we've got that default static route. Although we should be able to reach this 10.10.10.2. And I'm assuming that that is what's happening here with Packet Tracer, right? So we can hit that address, we can't hit this one. And the reason we can't hit that, we know for a fact that when we look at the routing table on router A has no route to the 192.168. So let's go ahead and let's give it a route. Now, they do static routes here, right? You can see we're going to do static routes. But let's do this. We're going to spice this up a bit. We're at 90 out of 100. We know we're going to get the 100 out of 100 by simply entering in these two commands. But let's take this a step further, right? Let's do what you would probably do, which is we're going to run OSPF over that tunnel interface, right? Because you can run a routing it's a point-to-point link. I can run a routing protocol over it. So let's do it. I'm going to say router OSPF1. Let's go ahead and say passive interface, and actually we'll keep it simple. Let's just put the network statements in. So I'm going to say network 10.10.10.0, 0.0.0.3, area 0, right? So let's come over to router B, and let's do the same thing. Router OSPF1, network 10.10.10.0, 0.0.0.3, that's our wildcard mask for that /30, area 0. Now, as soon as I hit enter, we should see an OSPF adjacency form between these two routers. Boom, right there, right? So I could run OSPF. I could run EIGRP over this tunnel interface if I wanted to, right? It is nothing more than a virtual, a make-believe point-to-point interface that we've got configured between these two routers. So now I'm running OSPF between these two routers, right? Do show IP OSPF neighbor. There it is, right? Why no DR-BDR election? Well, let's see. Do show IP OSPF. Sorry, do show IP OSPF interface, and we'll leave it at that. Why no DR BDR election? Oops, sorry, I'm on the wrong line there. Exactly, it is a point-to-point network type. And on point-to-point network types, there is no DR BDR election. But I'm running OSPF across this link. So what about routes? Am I learning anything? Do show IP route OSPF. No, nothing. Well, let's change that. Let's go ahead and put in 192.168.2.0.0.0.250. So now I'm going to advertise with OSPF. I'm going to advertise my LAN segment, right? So now when I come over here to router A and I say do show IP, what am I looking for? IP route OSPF. Look at the route that I learned. I now know how to get to the 192.168. What is the interface out which I'm going to go to get there? Bingo, the tunnel interface. So now let's reciprocate here. Let's add in the network for 192.168.1.0.0.0.255, area 0. Come over to router B and let's check and see. Have I learned do show IP route OSPF? I've got it, right? And that's it. You could treat it just like a serial interface, right? Except it's virtual, it's make-believe, right? It's a virtual tunnel interface. And so there it is, right? We've got it set up. We're running OSPF across the tunnel. Now, when I come over here to PCA and I try to ping, I'm going to come to router A, and router A is going to say, do I have a route to the 192.168.2.0 network, the network to which this guy PCA is sending his ping packets? And what does it look like? Are we golden? We are golden. We've got full reachability. I come over here to PCB, grab the desktop, and again, if I can go one way, it's a very good possibility that 192.168.1.2, is it 1.2, 1.2, that I'm going to be able to go the other way, right? And so that, I think, is a much better demonstration of what you would actually do, right, as you would run a routing protocol over that tunnel interface to facilitate the automagic distribution, right, or advertisement of LAN segments. Because what happens if I add a LAN segment here? All I need to do is add a network command in here. I don't need to add a static route there, and it pin's slowing down on me, a static route there and a static route here. And then I add another segment here possibly. And then I got to add another static route here, and I got to add another static route. No. We run OSPF over this link. I throw a network statement in here. OSPF floods the information over to router A, right? The type 1 LSA gets updated, sent over to router A. Why is there no type 2 LSA? Right, because it is a point-to-point link. The type 2 LSA, the link state ID for the type 2 LSA is what? Exactly. It is the IP address of the DR. There is no DR BDR here. There is no type 2 LSA. So the type 1 LSA gets flooded over. I learn about the new link here that router B is going to be advertising to me. And now I know how to get there. And router B knows how to get back. So that is what you would do, right? But for those of you desperately seeking that 100%, let's go ahead and we'll finish this out so that we ensure that there's nothing wrong with this activity. I can put a static route, 192.168.2.0.0, 255.255.255.0, and I'm going to go over the 10.10, or the next top IP address is the 10.10.10.2. So we get 5 points for that is my guess. Yep, we get 5 points for that. And then we come over here to router B and I say IP route to get over to the 192.168.1.0, which is a /24. I'm going to go to the 10.10.1 for the next top IP address. That's going to give me the 5 points to bring me to 100. All right, so again, we talked a lot about GRE, a little history of GRE, and then tried to give you a little runway to work with when you're going to be transitioning to learning about DMVPN and some information that you can use there. And we saw how to run a routing protocol over that tunnel interface. That is exactly what you would do. Makes it so much easier from an advertisement and an administrative perspective. All right, well, that is going to wrap up Packet Tracer Activity 3.4.2.4, configuring the generic routing encapsulation and creating that virtual, stressing that, point-to-point, right? It's point-to-point tunnel that runs between those two routers. All right, guys, hopefully this clears up any confusion you had on GRE, and I will see you all on Tuesday night.